now that we've worked with our different conic sections and we've kind of worked with their equations, we need to talk about the general quadratic equation. Using the general quadratic equation, we can determine whether you have an ellipse, a hyperbola, a circle, or a parabola based on this general quadratic equation. This is in the form of ax squared plus bxy plus cy squared plus dx plus ey plus f, and that equals 0. So notice that the constant is moved over on the left side with everything else to give us the 0. Now, we know that with a quadratic equation that we are working with, we have an x and a y in order to have on our ellipse, circle, hyperbola, and parabola. Now, the thing is, you can base your general equation, or you can use the general equation in order to find what type of shape it is. Now, we have not necessarily worked with the bxy, and that's just because we haven't touched base with it yet. But here's the thing. From what we know, there's two separate categories. There's if there is a b, and if there is not a b. Okay, and this information is going to determine how you find whether it's an ellipse, etc. So if you have an ellipse and there is a b, if there is a b, you can base it off of the discriminant, and it's b squared minus 4ac is less than 0. If there is not a b for an ellipse, then ac is greater than 0. If we have a hyperbola and there is a b, b squared minus 4ac is greater than 0. If there is not a b, then we have ac is less than 0. Now for a parabola, if there is a b, our discriminant b squared minus 4ac equals 0. If there is not a b for a parabola, ac equals 0. Now, you're probably thinking to yourself, okay, Mrs. Fish, we've got ellipse, hyperbola, parabola, where are we going to go here with a circle? Well, technically, a circle is an ellipse. It is just in the form that the a and b equal each other. So that's what makes it a little bit, it's like a special case. Kind of like a square is technically a rectangle, but it's a special case of a rectangle. So using this information, we can determine what type of conic section we have. So for instance, if I were to have x squared minus 6xy plus 9y squared plus 8x minus 6y plus 1 equals 0. Okay, so the first thing you want to ask yourself is, do I have a b, do I not have a b? Looking at this information going back, you're only really dealing with a, b, and c. So I hate to say it, but the d, e, f don't really matter. So looking at this, I'm going to go ahead and label my a, b, and c. So a in this case is 1, b is -6, c is 9. So based off of this information, I do have a b value, which means that I have to use the discriminant information. So I have to determine this b squared minus 4ac. So I've got -6 squared minus 4 times 1 times 9. Well, 6 squared gives me 36, minus 4 times 9 gives me 36. I have 0. So this b squared minus 4ac equals 0. Therefore, I know that this is a parabola. Final answer. The other thing that you might have to do, so this is going through from the standard equation and figuring out, what type of conic section you have. But the other thing is you could be in, our proper ellipse form or proper hyperbola form, and you might have to write it in standard form, in general standard form. So for instance, if I were to have x squared over 9 plus y minus 3 squared over 2 equals 1. Okay, so I want to rewrite this so that it is in general standard form. So for starters, we know that this is an ellipse because it's a plus in between, and the 9 and the 2 are not the same, therefore it can't be a circle. So what you want to do is you want to get rid of the fractions. No one likes dealing with fractions. So we need to multiply by the common denominator. Generally, you can just multiply the 9 and the 2 together to get that number. So we'll go with 18. So now we need to distribute that to everything. So this is going to be 2x squared plus 9 parentheses y minus 3 close parentheses squared equals 18. However, when we were dealing with our general standard form, it wasn't y minus 3 in parentheses squared. It was y squared and something y. So you need to actually do distribution of the y minus 3 squared. So we've got 2x squared plus 9 times y minus 3, y minus 3 equals 18. So I'm going to do the distribution there. So I have 2x squared plus 9. I'm going to let this 9 hang out for a little bit. So I've got y squared. I'm going to combine my terms together in my head. I'm sorry. If you need another line to see the full distribution there, you can. This should be minus 6y plus 9 equals 18. Now I'm going to distribute that 9. So I've got 2x squared plus 9y squared minus 54y plus 81 equals 18. Remember, it has to equal 0, so I got to move that 18 over for my final answer to be 2x squared plus 9y squared minus 54y plus 63 equals 0. So this is now in the general standard form. All you're doing there is just some basic algebra. You're just rearranging it so you don't have your fractions and everything is distributed out properly. So looking at this again, we went from our, in this case, an ellipse standard form, and we wanted it in a general standard form. So we're using basic algebra. In this, we were in our general standard form, and we were trying to figure out whether we had an ellipse, hyperbola, or parabola. And in this case, there was a b value, so we did use the discriminant of b squared minus 4ac. Going back here, remember, if there is a b, this is what you use. If there's not a b, this is what you use. So that kind of helps determine what you got.